Welcome back everyone. In today's tutorial, we're diving into one of the most powerful features of phasereditor v4, script nodes. This tool opens up a whole new way to manage custom code, making game development faster and more flexible. Here's what we'll be covering. We'll go over the basics of script nodes and we'll review the script node class and some of the built-in methods that are available to us. We'll see how we can create our own custom script nodes and how we can chain them together for advanced functionality. We'll take a look at the reusable script node libraries and how we can use those in our project, and much more. If you're new to phasereditor, no worries. While we won't be covering the basics here, I've got a complete crash course linked in the description and on the screen for those looking to start from scratch. If you'd like to follow along with this video, you will need to have access to the 4th version of phasereditor. And so for this video, we're focused on the v4 version of the phasereditor, and as newer versions of the application are released, the UI may change and the features may change. So if you'd like to follow along with this video, you'll need to have access to the 4th version of the phasereditor. So let's dive in and start exploring how script nodes can simplify our game development. So for our first example, before we start talking about script nodes and how we can add these to our project, I want to review what we'll be building. In our first example, we're going to recreate the title scene from the Sunnyland demo that's included as one of the phasereditor project templates. And so the Sunnyland project template is a great example of how you can build a platformer game in phasereditor. And so if you run that project template, you're going to see a game like this. We're going to have this nice title screen where we have this scrolling background and this flashing press enter text. If we click on the screen, we're now showing the instructions for our game, and if you click one more time, our game now starts and our player can play our game. And so for our first example, we're just going to extend this title screen here. We won't be getting into the platforming aspects. For our title scene, we're going to add in some nice fade in and fade out effects to our scene. We're also going to add in some simple animations for our title text. So as an example of what we've been building, we'll have this nice fade in effect, and then our title text will animate from the top of our screen down to the middle, and we'll still have our flashing press enter text. We'll also have our scrolling background, and when the player clicks, we'll now show our instructions, and if they click one more time, we have this nice fade out effect where they would now transition to our actual game. Now for us to create this type of functionality, there are a few different approaches we could take to do this. With the Phaser 3 framework, we can easily achieve this functionality by utilizing the built-in events, animations, and game object types to create our title scene. And so to kick things off, let's take a look at the storyboard for our title scene that we will be building. We'll see how these design blocks relate to our phaser events, animations, and game objects, and then how we can then bring in script nodes to bring all this together. So when our scene first starts, we're going to have it start off with a black screen, and it's going to slowly fade in and then review our background. To achieve this, we can use the built-in fade effects that are built into the phaser camera game objects. So then we're going to show our background for our title scene. Our background is going to be animated. And to do this, we're going to make use of the tilesprite game object type, so we can just update our positioning to have our tile move across our scene. Once that's visible to the player, we're now going to animate our title text in from the top of our scene down to the center. And we can use a tween to create this simple animation. Once we have our title text in the center, we're now going to have our press enter text show up. And when our press enter text shows up, we're going to have it blink on our screen. To get this effect, we can use a phaser timer event to have it repeat a function on a set interval. This function is just going to update the alpha on our object, and so it's going to make it visible then not visible. And so we're just showing an example here where our enter text is going to disappear and it'll reappear back on this scene. Now for our title scene, we're going to listen for a click event, and that's going to be our trigger to show our instructions to the player. And so with Phaser, we can easily listen for click events in our game, and when that happens, we can trigger a callback. And that'll be our trigger to now show this game object to our player. And so this game object will already be in our scene, it just won't be visible. Once we have that callback for that click event, we're going to hide our other game objects in our scene, and now we're going to show our instructions. Finally, we'll have one more click event, and when the player clicks in our title scene, we're going to fade out to black. And now this would be the transition point for us to start our actual game, and this is where our example will end. For this, we can also use the built-in fade effects on our camera, but we're going to trigger a fade out. So now that we reviewed our storyboards, we need to make a decision on how we want to approach this functionality in phasereditor. One approach we could take is we could use the built-in blocks that are available, and from those blocks, we could create prefabs, which will allow us to add custom code to our prefab. With our prefabs, we could do things like have our text be animated onto our screen, we could have our title, we could have our inner text flash, and much more. Another approach is we can achieve the same functionality by using script nodes. At a high level, script nodes are a special type of game object in phasereditor that allow us to write custom code. We can then take this custom code and we can attach it to any scene, game object, or even other script nodes in our phasereditor project. By using script nodes, we can create small reusable blocks of code that we can then reuse throughout all of our phaser editor projects. And where script nodes really shine is when we use them in the phaser editor, we can chain these nodes together to create brand new functionality for our game. So as an example, if we review our storyboards one more time, I'm just going to zoom out just a little bit. And if we think about our phaser functionality that we want to implement, and if we could abstract this away in a building block or a script node, we can then combine these together to get the same functionality. So as an example, when we start our scene, we want to fade in our camera. We put all of that logic just for doing that fade in logic into its own script, it now becomes reusable and we can use it in any scene. Next, for animating our tile sprite, we can do the same thing where we have a block where we want to animate our tile sprite's properties, and now we can attach it to any other tile sprite we ever add. And we can kind of repeat this pattern for each of our pieces of logic. So when we want to create a tween for animating our text position, we put that in its own code. Our timer event, updating objects alphas, all of these are things we can make very small code blocks for, and they all become reusable very quickly. And so once we have all those individual blocks, we can now combine them together to create the full functionality we're looking for. So how I like to think of script nodes is they're like a Lego block. They're a small block that can do their own thing, they stand on their own, but when you combine the two together, you have a new shape that you can make. And so for our title scene, we're going to take all of those phaser events and we'll have our script nodes for them, and by chaining them together, we're now going to get our full functionality we're looking for. And so now by using all these reusable blocks of code, we can get the same functionality that we would if we manually coded all this in our prefabs or in our level scene. And we can do all this visually through the UI in the phaser editor once we have our code blocks established. Besides using the script nodes for custom code in our game, we are also able to create prefabs from the script nodes that we create. This means we can make our reusable code blocks more extensible by adding custom properties that can be set in the GUI. And then we will have access to those properties in our code of our script node. So to see an example of all this in action, this is an example of what we'll end up building. So in our outline view here, we can see in our phaser scene, we have a bunch of game objects that are nested within each other. These game objects, when they have the gear icon, that means they are a script node. And each of these script nodes are responsible for doing one thing and only one thing only in our scene. When that script node completes, we can then invoke another script node, and that's how we can chain these together. So as an example, this script node here, we have our camera fade in when our scene first starts. This script node is only responsible for making our scene start off black and then slowly fade in from our camera. Once this completes, we're now going to start our animation for having our title text come down into our scene. So we'll see we have our game object here, but now we have the script node that's going to target it, and it's going to update its positioning based on what we set in our properties. Once that animation is complete, that's the trigger to now show our press enter text. And so by chaining our script nodes like this, we have this brand new animation chain just based on how these are nested within each other. And because we can create prefabs from our script nodes, that means we can create multiple instances of that node and have each one be unique. As an example, we want to animate our background image here. And so this is really two images. We have our background and our foreground. For both of these, they're going to use the exact same script, but we're just going to modify the instance of that prefab, the X value of how far it should scroll each update, and we're going to do those independently of each other so they can animate differently. So one thing to keep in mind is that script nodes are completely optional in your game, and anything you can do in a script node, we can do directly through our code. However, you can definitely save time by using script node. Once we drag a script node into our scene and set its properties, Phaser Editor will generate all the code we need, which makes it incredibly efficient. So now that we've done a high-level overview of what script nodes are, let's take a look at how we can start using these in our game. If you'd like to follow along the video, there'll be a link in the description of this video to a starter project template that's hosted on GitHub. This project template is a basic Phaser Editor project that extends the vanilla JavaScript project template. This template's been set up to have all the assets we're going to need for our game, and they've already been loaded into our project, and they've been added to our asset pack. So if you'd like to follow along, please download that source folder now. Once you have the project, let's open up Phaser Editor. We're going to do Open Project. Let's navigate to the folder we just downloaded. It'll be Phaser Editor Script Notes Tutorial. We'll do Open. Now this should open up our Phaser Editor project. And if we do Open Scene, we should see a few different scenes. We should see a preload scene, a button example, and title. Let's open up button example to start with. So in this scene, we just have one image block, and it's meant to represent a button. If we come down to the Files panel, let's open up our title scene. We'll see in our hierarchy, we have a couple different game objects. These are just a couple different images and tile sprites that are set up in the positions for our title scene that we're going to build. And right now, it just has our assets and none of the script nodes that we'll be adding. So anytime you create a new Phaser Editor project using one of the built-in templates, generally what's included is this Phaser.js editor script space folder. This folder has all of the core functionality that we need for our script nodes. So inside here, let's open up our scriptnode.js file. So the script node class is meant to be the basic building block for creating these reusable scripts. This core class is meant to be extended with our own implementations of the script node, and so this acts like a prefab in Phaser Editor where we want to create instances of our script node, and then we can create variations by adding on our own functionality. And so the script node class acts as a blueprint for the methods we should implement in our own implementations of script node, and then offers a bunch of utility methods for quickly getting access to the game objects or blocks that are associated with that script node. How the class works is there's a bunch of built-in getters that allow us to quickly reference the other blocks and Phaser scenes that are associated with that script node. In addition to that, we have a getter for getting the children blocks that are associated with the script node. So with parent and children, what I'm referring to is like when we looked at our project before, we see in our hierarchy, we have the ability to nest our game objects or blocks within each other. And we can also do this with game objects or even script nodes on game objects in our scene. And so those parents and children, this hierarchy, that's what those methods allow us to access those through our tree here. Besides our getters, the script node class has a blueprint of methods that we should override if we want to implement them with our custom code. And how these methods get invoked are based on the Phaser scene events that are emitted when our game is running. So as part of the Phaser scene lifecycle, one of the main events is the update event, and so this is invoked multiple times per second or once for every tick of our game loop. By hooking into this event, we can now invoke our various methods and then run our code. As an example, when we want to do our tilesprite and move our game object across our scene, we'd want to use our update method to update the positioning of our game object. Versus like our start method and our execute method, we'd only want to run these one time when they're invoked. Besides the Phaser lifecycle scene events, the class also listens for a custom event called scene awake. And so the custom scene awake event, this is emitted by Phaser Editor once all of the properties on the game objects we create through Phaser Editor have been updated. And so by listening to these various events, our various methods here will get invoked. And one thing to note is we only register and listen for these events when we create implementations of these methods in our core class. I know there's a lot of information, but the key takeaways are the script node, this is just a base class that we need to extend, and it has the whole blueprint that we need for getting started with adding our own custom functionality. And for me, the best way to understand script nodes is to dive in and start using them in our code so we can see how they function. So let's start doing that. So before we dive into our title scene, we're going to start with a more simple example. We're going to build a reusable button, and typically for our buttons, we want them to react to players interacting with them. And so for our button, we can imagine when our player's mouse moves over it, we might update our texture to show that we're hovering over it. When the mouse moves out, we will revert back to the original texture. And so when the player clicks on the button, we would do some action. To create this kind of interactivity with Phaser, we need to make our game objects interactive, and then we need to listen for our input events on that game object so we can do something. Some use cases for typical buttons is it might launch our scene. So on our title scene, we might have a button that lets us start our game. We might have a button that would mute audio, open up our options menu, all kinds of different things. And so in all these examples, we're doing different things, but one thing that's in common is once the player clicks on that button, we go and do something. And that functionality is a perfect use case for usable code for our script nodes. So for our script nodes, we're going to start by adding in a click event listener when the player clicks on our game object. All right, so for our script nodes, to keep them organized, we're going to group these into subfolders based on what they're going to be used for. Under our script nodes folder, let's do right click, let's do new folder, and let's add a folder called game objects. All right, so in this folder, we'll be placing all of our script nodes that we create that are meant to be targeting game objects specifically. So under this folder, let's do right click, we'll do new, let's do prefab file, and now we want to create a name for our script node. We'll do on pointer down action script. So now if we do create, this should create our on pointer down action script scene file. And now for our prefab file, we need to choose our root child for our class to extend. So under our built-in blocks, let's do script, and then we'll do script node, and we'll drag that into our scene. Now if we save, our JS file should be created, and if we open it up, we should see that now we're extending our script node class. So now for our custom script node, we're going to want to override one of the built-in methods that are available to us on our script node core class. And depending on what we want our functionality to do, we need to choose the appropriate method. If we want our code to run automatically, once our script node is created and all of our properties are set, we should target our awake method. If we want it to run once our scene starts and our first update method is called, we'll want to use our start method. And if it's something we want to manually execute, and so it needs to be invoked by some type of trigger, we'd want to implement the execute method here. So for our pointer down script, we want to register our event listener for our pointer down as soon as we can, so then that when the player clicks on our game object, we can now react to it. So for that, we're going to use our awake method so we can get this registered on our game object. So let's jump back over to our onPointerDown action script. And now we want to come down to the part where we can add our custom code. Let's add in awake. So the first thing we'll do in our script is let's add a safeguard to make sure our script node is associated with a game object and not something else like our scene. To do that check, we're going to do if this game object equals undefined. Then we just want to return early and we're not going to do anything with our script. If our game object is defined, now we want to make sure it's enabled for input. So we'll do if not this game object input. So if our game object doesn't have input, that means we didn't call set interactive on our game object. We won't be able to listen for events. So now we're going to want to call set interactive, and then that way we can listen for those events on our game object. Now that our game object is enabled for input, we can now listen for events on our game object. To do that, we're going to do this, we're going to do game object, and we're going to do on, and now we need to provide the event name that we want to listen for. So let's do phaser, we're going to do input, we'll do events, and we'll do pointer down. And so now we can provide a callback function that would like to be invoked when this event is triggered. So for this, I'm just going to do console.log, and we'll say button clicked. Now that we have our custom script node, let's go ahead and test it. Let's come back to our button example scene, and we need to attach the script node to our game object. If we do right click, let's do scripting, we can do add script. One thing to note is it shows the shortcut here, and so we'll be using that for the rest of the video. And so it's just shortcut U, and so I'm going to do add script. Now any script nodes that we've created in our project are available to us, and let's do on pointer down action script. We'll do add script, let's save, open up our project. All right, if we come to our browser, we should be able to see our project. And now if we click on our scene, nothing happens, but if we click on our game object, we'll see our message is being logged for our button being clicked. Now that we have our basic functionality working, we're going to work on extending our script. So for our button, let's say we want to have an option, so we only click our button one time and we'll do something, and then our button would be disabled. For this, we don't want to listen for our input down event every single time it's clicked. Instead, we'd want to use our once method, so then that way we register an event listener one time, and after it's invoked, our callback would never be invoked again. To do this, we can extend our node script just like we do with our other prefabs, where we can add in custom properties. So if we open up our on pointer down action script scene, we'll see we have our prefab properties here, and now we can add custom properties. Let's add a new Boolean property. We'll say once, and for our label, we'll do once. Now for our tooltip, we'll say listen for the pointer event one time. And by default, we'll just leave this set to false. So now if we come back to our button example scene, if we click on our script node, we'll see now for our prefab instance, we now have that property, and we can enable and disable it based on what setting we like to do. To use this in our actual script, let's come back to our code. We'll see we have our new property, and now we can check that property when we register our event listener. We'll just do an if statement. We'll say if this.once is true, then we want to do the same logic, but we want to use our once method instead. And we'll just do a return after this. And if it's not true, then we'll register an event listener so we can do our click event multiple times. So we're starting to repeat our code a little bit here with our event name. So I'm going to copy this out and place it in a variable. So I'm going to do const, we'll do event name, we'll set it equal to our phaser input events down. We'll copy that variable, let's paste it here. So if we save, let's come back to our browser, we should be able to refresh and test. We'll see because we didn't set once, we can list for our click event multiple times. If we now, for our prefab instance, let's turn once on, we save our scene, we'll retest. Now, once we click, we get one button click message, and every time we click after that, nothing happens. And so this is one of the benefits of our script nodes is because it's just a prefab, we can easily extend and add new functionality by adding properties to our prefab that we can now use in our code. And so we'll see more advanced examples of this later where we do things like duration and other things when we create our animations. So currently in our node script, all we're doing is logging a message. But previously when we talked about our buttons, we want to be able to support things like start another phaser scene. So we'd start our game when a button's clicked. We would want to disable audio or enable audio. We want to be able to move game objects. And there's a variety of things we could do when a button is clicked. And to make our button really reusable, we don't want to hard code what we want to do here in our script. Instead, we want that logic to be in another script, and then we want this script to invoke it. And so really, we want to chain our script nodes together. To see an example of this, we're going to move our console log message to its own script node, and then we'll see how we can invoke that script node from this one. So to make our new script node, let's come down to our files panel. Under script nodes, let's make a new subfolder. We're going to do new folder. For these ones, I'm just going to call this utils. And then we're going to do right click. Let's do new prefab file. And we'll say log message action script. Let's do create. For our building block, let's drag in our script node. And let's save. Now let's open up our log message action script. All right, so for this script node, we don't want to run this code automatically when we create an instance of our script node. Instead, we want something else to trigger it. So as an example, back in our onPointerDown action script, our trigger for this is when our script node is created and it's available in our scene. When that happens, we want to add an event listener to do something. Versus our log message script, our trigger for this is going to be another script or another interaction in our game. We don't want to log a message automatically when our game starts. So to have that type of functionality, we need to use the execute method. And now the execute method will require us to manually invoke that on our script to do whatever we want to do. So for this, we just want to do console.log, and I'm just going to do button clicked. And now that we have this custom script, let's come back to our button example scene, and let's create an instance of this. So if we click on our instance of our pointer down script, we'll do our shortcut for adding a script. Let's do utils, and we're going to do log message action script. So if we save and come back to our browser, we should be able to click on our button, and we'll see we still log our message, and we're not actually invoking our new script yet. To do that, let's come into our onPointerDown action script, and let's remove our console log here, and we'll remove our console log here. And so to invoke our script, we're going to use one of our utility methods that's available in our base script node class. We're going to do this, we're going to call execute children. And let's copy this, we're going to paste it down here. And so what this method does is it's going to grab all of the child game objects from our hierarchy, and it's going to call that execute method on it. So if we save, let's come back to our browser. If we refresh, we click on our button, we'll see we still get our message because what's happening is in our script node, now we're calling execute children. In our hierarchy, we have this node script as a child of this one, and now we're calling the execute method on this node script. And just to make sure there's a difference, we're going to do button clicked. I'm just going to say 2. We come back to our browser. If we click on it, we'll see button click 2 is now invoked. And so by using that execute method, we can now chain our script nodes together to get new functionality from our game by using our reusable building blocks. So as an example, if you imagine now we're building our buttons for our game, we just add the script node for the onPointerDown, and then whatever we want, and then whatever action we want to take, we just attach that type of script node. So we could create a script node for starting a phaser scene. We could create a script node for disabling our audio in our game, enabling our audio in a game. We could create a script node for moving another game object, or we even just have one that logs a message. And to change our functionality for when our player clicks, we just need to change which type of script node we're adding here. So one last change we're going to make to our log message action script is we're going to change our message to be a property. So then that way this is more reusable. So let's open up our log message action script. Let's go to our prefab properties. We'll do add property. Let's do a string. For this, I'm just going to call this message. And we'll say the message to log. And we'll do save. Come back to our log message action script. Let's change this to reference this.message. Now if we come back to our scene, we'll see we have that available to us. So for our message, we'll say the button was clicked. All right, so if we save our scene, let's come back to our browser. If we refresh our browser, if we click on our game object, we'll see our custom message was now logged. All right, so for our button example, we're going to add support for one more thing. When our player moves their mouse over our game object or when they move it out, we're going to update the texture on our game object. So to add this type of functionality, it's going to be very similar to what we did for our onPointerDown action script, where we need to register an event listener. And when we do this, we just want to listen for our pointer over and our pointer out events, and then we can update our texture on our game object. So to do this, under our script notes folder, let's go to game objects, let's do new prefab file. And for this, we're going to do on pointer event action script. So let's do create. Let's drag in our building block for our script node. We'll save, and now let's open up our onPointer event action script. If we come back to our onPointer down action script, let's copy the code for our wake method. We'll come back to our onPointer event action script. Let's paste that in. So now for this script, we want to be able to define which event we want to listen for instead of manually defining it in our code. To do that, we can add a new prefab property to our script nodes. Let's do add property. For this, let's choose option property. For our name, let's do input event. Do input event for our name, and we'll say the phaser input event to listen for. All right, so for our options, let's add two strings. We'll do pointer over and pointer out. Let's add in a default. We'll do pointer over. Let's save. Come back to our script. We'll see now we have a new property input event that has our two different types available to us. So now for our event name, we're just going to change this to be this.input event, and we'll do this.input event. Let's get rid of our variable here, save. Let's come back to our button example, and let's create an instance of this. So now let's choose our game object as our root. We'll do add script. We'll do our game objects, and we'll do onPointer event action script. Now when this happens, let's log a message so we can see what's happening. So we'll add a child script to this script node. We'll do utils. Let's do our log message. Now for this one, we currently have this set up to do pointer over. So we'll say pointer over so we can see that in our logs. All right, so if we save, let's come back to our browser. If we move our mouse over our game object, we'll see our messages being logged for our pointer over. So one thing we need to do on our onPointer event action script is we actually need to add our variable for once. If we come back to our scene file, let's add a new property. We'll do a Boolean. We'll add in once, do once, we'll do save, and then back in our scene on our onPointer event action script, if we expand it, let's enable once, we'll do save, come back to our browser. Now we move our mouse over our game object, we get one message logged, and then we have no other input. Nice. Now to make sure our pointer out event is working, let's add another script to our game object. We'll do game objects, we'll do onPointer event. Now for our input event, let's change this to be pointer out. Let's add in a child script for logging a message. We'll do utils, we'll do log message, and we'll say pointer out. We save our scene, let's come back to our browser. Let's refresh. Now we'll see when we move our mouse out of our game object, we have our other message. The last thing we need to do for our button hovering functionality is now we need to update our texture that's applied to our game object when our hover events happen. For this, let's make a new script node. So under our script nodes folder, under game objects, we'll do a new prefab file. We'll say update texture action script. Let's create. We'll add in our base block for our script node. We'll save. Let's open up that JS file. And so for this script node, it's going to be similar to our logging of message script node, where we don't want to actually run this code until something invokes it. So let's add in our execute method. And so in this method, now we want to update our texture in our game object. Let's jump over to our onPointer event action script. Let's copy our code here for we do our check for our game object. We're going to paste that in. As now for updating our game texture, we're going to use our built-in method. So we'll do this .game object. We're going to do set texture. And now this method allows us to provide this string to one of our textures in our cache, and we can update it. To get that texture configuration, we'll add that to our prefab instance. So let's go to our update action script scene. Let's do a new prefab property. Let's search for texture config property. We'll do texture config. Let's save. Back in our script, now we can do this, our texture config, and we'll do key. We'll save our script. Let's come back to our scene. All right, so if we choose our script for on pointer out, and I'm just going to update our display name so it's a little bit easier to see. We'll do on pointer out event. I'm going to update the display name for our other scripts as well. So we'll do on pointer over, and let's do on pointer down. And this just updates our display name so it's easier to see what we're working with in our hierarchy. So on our pointer out event, let's add a new script. We'll do our game objects. Let's do update texture action script. We'll do add script. On pointer over, let's do the same thing. And so when our mouse moves out of our game object, we want to use the same texture we're currently using. So let's choose that script node. For our config, let's unlock our property, and we'll choose our first button texture. Now for our other script node, let's choose our second button texture. All right, so if we save, let's come back to our browser. Let's refresh. Now if we hover over our button, we'll see our textures updated. And if we hover out, our button updates again. Real quick, I'm going to update our on pointer over. I'm going to disable once. That way our hover functionality will be consistent. Alright, so we refresh, and now as we hover over a button and hover out, we'll see our textures being updated and our button is animated. One last change we'll make to our script is let's come back to our update texture action script. We want to make sure texture config is set, so if it's not set, we don't want to do anything. So let's just add one more safeguard. We'll do this, texture config equals undefined. So if we don't define it through our UI, we won't run our code. Alright, so now that we have our core functionality done for our button, before we move on to our title scene, I want to quickly go over some of the things that we did here. So far we've created a variety of script nodes that do different things. We started off by creating this on pointer down action script. And so the script allows us to listen for a particular event that's tied to our input events. And when this happens, we call execute children, which allows us to chain our script nodes together so we can do other things. And so by doing this, it allows us to easily create reusable functionality by keeping our blocks of code in our script nodes very small instead of putting all of our logic in one place. And now this is completely optional, and you could have all of your code here, but by making them small and reusable, we can use them in our other projects. And so one thing to keep in mind is your script nodes can have multiple children. So we saw that example with our pointer out and pointer over events where not only are we updating our texture, we're also logging a message. And so by invoking the actions on all these children, we can get all kinds of different functionality. Then to create our pointer over and pointer out event listeners, we created a generic script, the on pointer event action script. And the script allows us to choose from one of our pointer events by us manually creating a list of available options that we'll expose in our GUI. And then by doing this, now we can support multiple event types by using the same exact code, and we just provide that as an input on our prefab instance. And so we could easily remove our on pointer down action script and just add that event type to this script, and now it supports all three. And so this is something to keep in mind is as you're creating your script notes, you can be as specific as you want to in the code that you add, or you can be as generic so you can support a variety of things. And it's totally up to you on how you implement this in your script notes. Then finally, for our script notes, we took a look at how we could use the awake and the execute method to invoke our code at different times. So we saw how we could use the awake method to have our code automatically run once our game starts up. And we saw how we could use the execute method to have our code run when something triggers that from our game. And in our case so far, it's just been script nodes triggering our other script nodes. Then finally, we saw how we could extend our script nodes and make them really reusable by adding prefab properties to our script nodes. And then that way in our GUI, we can now update these properties when we create instances of them. So when we did our log message, we provide which message we want to log. When we update our texture, we have properties to define that. And then even for our click events, we have the ability to choose which event, and if we want to be a one-time listener versus listening every time that happens. All right, so now that we've reviewed what we've done so far, let's go ahead and open up our title scene. So I'm going to right-click up here, and I'm going to do close all to close all of our tabs. And now let's go ahead and click on our title scene to open that up. All right, so start working with our title scene. First, let's go into our preload scene, our JS file. We want to change which scene we're starting when our game loads everything. Let's comment out our line here for starting our button example, and we'll uncomment out our line to start our title scene. Now back in our browser, if we refresh, our game should now be updated and we should see our Sunnyland title screen. Alright, so for our title scene, currently it's very static, and now we want to start building out that functionality based on our storyboard that we initially went over. So first up, we want to go ahead and add a fade effect, so when our scene first starts, it'll be black, and then we slowly fade in to reveal our background image. To do this, we're going to use our phaser camera's game object, and we're going to use the built-in methods on our camera to trigger these fade effects. So let's make a new script to do this. Under our script notes folder, let's make a new subfolder, and we're just going to call this camera. So we're going to place any script notes tied to our camera here. Let's do a new prefab file. For our script name, let's do fade effect, camera, action script. Under our built-in blocks, let's add in our script node. Let's save. Let's open up our JS file. And now let's add in our execute code block. Alright, so for our fade effects, we need to grab our camera game object from our phaser scene. By default, phaser scenes support multiple cameras, but for the time being, we're just going to focus on our main camera, which is the default camera that's added to your scene when you create an instance of your phaser scene. Later on, you could extend this, so then you can choose your target camera game object, but for now, we're just going to rely on our main camera. To get a reference to our main camera, we need to grab that from our scene, so let's make a new variable. We'll do const, we'll do camera, we're going to set equal to this, our scene, and now we'll do cameras, and now we'll do main. So while I'm working on my script nodes, one of the things I like to do is I like to create a variable for our scene. So we'll do const underscore scene, and we'll set equal to this.scene. Now the reason I like to do this is we can add JS doc types, so that way we'll get our IntelliSense for our variables while we're working with them. To do that, we just do at type, and now we can provide the typing information for our variable, and I'm going to do phaser.scene. And so the reason I'm doing this is if we hover over this.scene, we'll see that this property, our type, is set to any, which means the editor cannot provide us the IntelliSense for our built-in methods for our phaser scene. By typing this and putting it on our variable, we now have the appropriate type, and now we can do things like this. We reference our scene variable, we'll see now our type is phaser scene, and now we'll get our IntelliSense for that object. So now I can do things like camera.main, and I know exactly what I'm working with in my code. And so one thing to note, this is completely optional, but it just makes it easier while working with our code if we have that IntelliSense. Alright, so now that we have our camera game object, we can now use our built-in methods for our fade effects. So we're going to do fade, and if we do in, and now we can specify a duration and what color we like to use. For our duration, let's do 1000 milliseconds or 1 second. And for our RGB, this will be the color that'll be used for our fade effect. We want this to be black, so we're going to set these all to 0. And just to test our functionality, we're going to change this from execute, and we're going to do awake. So now if we come back to our title scene, let's create an instance of this. So from our scene, let's do our shortcut for adding in our script. We're going to do camera. Let's do our fade effect, camera action script, add our script. All right, to test our changes, let's save. We'll come back to our browser. If we refresh, we'll see now when our scene starts, we now have this fade effect, and it's happening pretty quick. So let's come back to our code. We'll go into our fade effect. Let's update our duration, and I'm just going to do 5 seconds just so it's very evident. We refresh. Now we have this very slow fade effect before it reveals our title scene. Next, for our script, we need to keep track of when our fade effect is finished. So currently in our storyboard, once our fade effect is done, this is going to be our trigger for our title text to come down onto our screen. In order to be notified when the fade effect is finished, we can add an event listener to our camera, and we can listen for the fade complete event. To do this, we'll do camera. We'll do once to reference our event emitter. For our event, we want to do phaser, cameras, scene 2D, our events. Now we want the fade in complete event. Now in our callback function, we're just going to call execute children. That way, if we have any child nodes on this script node, we'll invoke them now. So if we come back to our title scene, let's add a child node. So if we do our shortcut, we're going to do our utils. I'm just going to log a message, and we're just going to say fade complete. All right, so before we test, let's make this a little bit shorter. So we're going to do 1 second. Let's save. Let's come back to our browser. If we refresh, we'll see once our fade effect is finished, our message logs to our console. So now that we have our event listener, we need to make our script a little more dynamic. We're going to add in some prefab properties so we can pass in things like our duration and which type of fading effect we want to do. Currently, we hard-coded this to do our fade in effect and listen for our fade in complete event, but we also want to support fade out functionality on our camera inside our script. To do this, let's go into our fade effect camera action script scene. Let's add some prefab properties. First, let's add a number. We're going to do our duration. Let's add a default value, and we'll just do 1 second. Now let's add another property. Let's do our option property. Now for our property name, let's do fade event. Do the same thing for our label. Now for our two options, so if we come into our camera action script, if we hover our fade in and complete, we'll see this is just a reference to the camera fade in complete text here. So let's copy that. We'll come back to our scene. Let's add that as one of our options. And so for our other option, this is going to be our camera fade out complete event. And then next, let's add in a default value. We'll do fade in complete. So let's save. We'll come back to our script. Now let's update our script to use these values. So let's replace our duration with this.duration. And now we just need to change our logic if we're doing our fade in or we're doing our fade out. So let's add if statements like if this fade event is equal to our camera fade in complete, then we'll run our existing logic. And let's add a return. And if it does not equal fade in complete, then we'll do our fade out effect. For our fade out effect, we're just going to copy this logic. Let's paste it. We can remove our return statement. Now for our camera, we want to do fade out. And for our event, we want to do our fade out complete. All right, so let's test our changes. All right, let's come back to our browser. Let's refresh. We should still see that we have our fade in effect and we still have our console log message when it happens. We come back to our title scene. Let's toggle our fade event. Let's do our fade out. Let's do save. We do a refresh. We'll see now we start with our title scene and now we fade out to black. Nice. All right, so let's revert that back to our default value and let's save. One last thing we need to do in our script is we need to change how our code is being triggered. Currently, we're using the awake method, and so when our scene is ready and it's awake, it's going to automatically run our code for doing our fade in effect. This works for this scenario, but for our fade out effect, we need to be able to control when that happens. And to make our code consistent, let's change this to execute. And now we need something to call this method in our script node. There's a few ways we could do this. We could update our title scene.js file to call our script node's execute method when our scene is ready. But to keep following the pattern of creating a script node, let's make a new utility script node that's just going to listen for the awake method, and then that can be the trigger to do other scripts. For this, let's go into our script nodes, let's go into our utils file, we're going to do new, let's make a new prefab file, we'll call this onAwake action script. For this, let's go into our script blocks, we'll drag in our script node, let's save, let's open up our JS file. Now all we want to do is listen for our awake method. When this happens, let's call this, and we'll call execute children. Now if we save, let's come back to our title scene. If we choose our scene, let's add in a new script node, let's go to our utils, let's add our new onAwake action script. Now we want to move this under our other action script, so let's do right click, we're going to do parent, we're going to do move to parent, and we'll do our onAwake action script, we'll do move. Now if we save, let's come back to our browser, we refresh. What should happen is as soon as our scene starts, our awake method's invoked, we have our nice transition, and we still see our console log message. Now that our camera fade in effect is working properly, next up on our storyboard is we need to animate our background on our title scene. Currently in our title scene, we have these two images, foreground and background, and both of these are tile sprites and phaser. And what's really nice about tile sprites is we can create a nice parallax effect by just updating the X value on our tile sprite in our update method. When we do this, the tile sprite's going to move across our scene, and it's just going to repeat the pattern on the other side, and we get this really nice effect. And to do this in our script node, we just need to replicate that functionality by using our update method. So to do this, under our script nodes folder, let's make a new folder, and we're going to make one for our tile sprites. So we'll do tile sprites. This will have any scripts that we create for our tile sprites. Now under here, let's do new. Let's do a new prefab file. For our name, let's do update tile position X action script. Let's drag in our basic block for our script node. Let's save. And real quick, I'm going to close a few of our files. Now let's open up that new script. And so now to update our tile's position, we just need to use our update method. So when we call our update method, what's going to happen is in our script node class, we're going to listen for the phaser scene update event. And when this event fires, it's going to invoke that update method on our script node. So now in our code, we can reference our tile sprite. So we'll do this, we're going to do our game object, now we'll do our tile position X, we're just going to do plus equals, and so now we need to increment our X position by some value, so we're just going to call this.x. And let's add this property to our prefab. So if we come over to our scene instance, let's add a new property. Let's do a number property, we're just going to call this X, our default value, we'll leave it at 0. Now if we come back to our script, we'll see we have our new property X on our script. And now let's go into our title scene. If we select our background image, let's do our shortcut to add our script. Now under our tile sprite script, let's do our new script. We'll do add script. Now for our X value, let's change this to 0.3. Let's save, come over to our title scene, let's refresh, and now we'll see our background is moving. All right, so we come back to our script, we're just going to add a safeguard to make sure we actually have a game object. So we're going to do if this game object equals undefined, then we just want to go ahead and return and not do any of our code. Now that we've updated our background tile sprite to be animated, we need to do the same thing for our foreground. So on our foreground, let's add in a new script. Let's add in an instance of our tile sprite, update tile position X. Now for our X value, let's do 0.6. Let's save. If we come over to our scene, if we refresh, we should see now that both of our images are now updated. Now that our background images are animated for our title scene, next up is going to be our title text. After our camera fades in, we want our title text to appear at the top of our screen and slide down into the position it's currently in. To do this with phaser, we're going to use a tween, and the tween allows us to create a smooth animation based on one of our properties, and so we'll target our Y property to just have our game object slowly move across our screen. Now to do this with a node script, there's a few different ways we could approach this, and so far for all of the scripts we've used, when we target a game object, we're attaching that script directly to our game object, and then we're executing the logic to make everything work. Another approach is for our prefab instance of our node script, we can pass in an instance of the game object we like to run our code against. And with that approach, what we could do is we could add a node script as a child to our fade effect camera script, and then that script will be responsible for updating our title text game object. If we continue with the approach where we attach our node script to this game object here, we'll need another node script to actually trigger that functionality. And then this becomes harder to track in our UI for the effects we want to, because we'll have this callback where we'll need to see, okay, this script triggers this script, now it's going to come back to this script to trigger the next script, and kind of so on and so forth. If we want a nice tree structure, we can have this script actually trigger our game object, and that way it has all its logic that I currently need. So as I mentioned, there are multiple ways we could solve this, and so this is just one approach. And so this functionality of being able to pass in a game object we like to target, we might want to use this for a couple different scripts. So we'll want to place this logic in a central location. And to do this, we're going to extend the base script node class with our own custom class, and then we can use that for our scripts. So like I mentioned, the script node class is meant to be a blueprint that we can extend in any way that we like for our projects. To do this, let's go into our script nodes folder. Let's add a new subfolder. We're going to call this base. So we'll do new, we'll do folder, we'll do base. Now let's do new and add a new prefab file. For this, we'll call this node script with target. Now in our scene, let's drag an instance of our script block and we'll save. So for this script node, when we create instances of it, we want to be able to pass in one of our game object blocks to our prefab instance. To do this, let's add a property. We'll do an object variable property. For our name, we're going to do target game object. For our label, we'll do the same thing. Now for our expression type, we'll just leave this as a generic game object. Let's save, and we'll open up our .js file. Alright, so for our custom class, we need a way to determine what is the actual game object we're targeting. And if we open up our script node class, we'll see there's already a method called getActionTargetObject. And what this method does is it checks to see if the action target component, the user component, exists on our script node instance. If it does, it uses that component to determine which game object we're actually targeting when our code runs. If that component does not exist, then it just defaults to our normal behavior on our script node where it references the game object that our script node is associated with. And we're going to extend this functionality where we're going to check to see if our custom property is set on our class. If it's set, then we'll use that for our target game object. If it's not set, then we're going to use our parent's class default functionality for this method. So to do that, let's copy this logic here. We'll come over to our custom class. Let's add that where we can add it in our custom code. And so we're just going to add a check to see if our target object is defined. So if this target game object does not equal undefined, we'll return that instance. We'll return this target game object. And so then if our target game object is undefined, then we're just going to do our default functionality from this method. So let's save our class. Now let's jump back to our title scene. Now that we have our custom node script class, we need to create a node script for creating that tween animation for our title text here. So under our script nodes folder, let's add a new subfolder. We'll do new folder, and we're just going to do animations. Once we have our folder, we'll do new. Let's add a new prefab file. For our new script node, we're going to call this move to action script. Now for our root game object, let's select our scene folder here, and we're going to do add a script, and we're going to use our custom node script with target instead of the default script node here. So let's save. Now if we open up our .js file, we'll see in the code that's generated, we're now extending our node script with target class instead of the basic script node class. So now in our script, let's add in our execute method. And so for our execute method, let's add in our spread operator for our arguments. So if we come back to our script node class, we'll see that our default method for execute receives our multiple arguments when this is invoked. So far for our scripts, we've not had to utilize these arguments, so we've omitted them from our scripts. And so for the new class that we just created, we're going to make use of our getActionTarget object here, and this expects us to pass arguments for everything to work. And so we're going to pass those arguments if our script happens to receive those when our execute method is called. So now in our execute method, we need to determine what is the target object that we want to create our tween for. For this, let's make a new variable. We'll do const, let's do object. We're going to set it equal to this, and we'll do getActionTargetObject, and we'll pass in args. So to make sure everything's working, let's just do a console log, and we're going to log out that object. Now if we come back to our title scene, let's go to our fade effect on our camera. Let's add in a new script. Let's add in our move to action script. We'll add that script to our scene. Now if we go into our prefab instance, we should be able to choose a target game object. For our target game object, let's target our title scene. We'll select it. Alright, so one last change we need to make is we need to update our scope that's associated with our title image. So if we open up our title.js file real quick, if we go to our logic where we create our title image, and so in our code, we'll see for our game object that's associated with our title image, because the scope is set to local, we're just creating an instance of our game object and we're not storing a reference to it anywhere. Later on, after we create our move to action script instance, when we try to associate our title image with our target game object, we'll see our variables undefined. And for this to be defined, we need to update our scope on our game object. And so for our variable, if we update our scope to be method or class, both of these will make that variable available to us in our code. So we're just going to choose method because we don't need it as a property. If we come back to our title.js file, we'll see now when we create our title image, we're now storing in a variable within our method, our editor create, and now we have access to it when we associate it with our node script. This is something to keep in mind with this approach. We'll just need to make sure our variables have the right scope so we can access them. So now we update our reference. Let's come back to our scene. If we refresh our browser, we'll see now in our console log, we have a reference to an image game object, and we'll see the asset key for our texture is title screen, so we're referencing our Sunnyland texture image here. So since we verified that our functionality for getting our target game object is working, now we can create our phaser tween. So to create our tween, we need to reference our phaser scene. I'm going to open up our fade effect camera script real quick, and I'm going to copy our logic for where we have our type for our phaser scene. I'll come back to our other script, and I'm going to paste that in. So now through our IntelliSense, I'm going to reference our phaser scene. We'll do add, and then we'll do tween to create a new tween game object. Now for this object, we need to provide our configuration. For our targets, we'll provide our game object that we're targeting. Now we need to specify our position for where we like the game object to move to. For our x, we'll do this.x. Our y, we're going to do this.y. And now we need to add in a duration for how long we want our animation to last, and we'll do this.duration. Then finally, we're going to add our onComplete callback. And so this will be invoked once our animation is finished. And we'll use this to call our executeChildren method, and we'll also pass in our args. So for these properties here, we're referencing properties on our class we don't have. So let's come to our move to action script scene. Let's go to our prefab properties. Let's add in our properties. We'll do a number property. Let's do x first. We'll use 0 for our default. Let's add in a property for y. We'll also use a 0 for default. Let's do another number property. This will be for our duration. This one will do 1000 milliseconds. Now if we save and come back to our script, we'll see we have our 3 new properties in our class, and now they'll be referenced here in our tween. And so what our tween's going to do is this is going to update our game object's position based on our properties that we provide here. So wherever our game object is currently at is going to move to this new location, and it's going to happen over a set period of time, and that's going to be based on our duration. So the shorter the duration, the faster our game object will move. The longer the duration, the longer it'll take. And so there's other properties we can specify on our tween, but this will work for our use case for the time being. So I'm going to jump back to our title scene. So now for our move to action script, we want to update our game object to be in the position it's currently at. So I'm going to copy our values here. So we'll have 144 and 70. We'll come to our script. We'll paste in our x. We'll do 70 for our y. We'll leave our duration as is. And now for our game object, let's drag it out of our scene so it won't be visible when our scene first starts. So if we jump over to our browser, let's refresh. We'll see now after our fading completes, our title text now animates onto our screen and it slides into the position where we want it to be. So it's a little bit slow, so I'm just going to update our duration. So go to our move to action script. I'm just going to make this 700 milliseconds, so it's a little bit faster. Let's save. Now if we retest, we'll see that our animation is just a little bit faster. Now that we've added in our animation for our title image game object, we now need to do our press enter image game object. So when our scene first starts, our press enter text should not be visible to the player, and after our animation completes for our title showing up on our screen, we should now make this visible to the player. After that happens, we want to do an animation where we update our press enter text, its alpha, to not be visible, and then after a small period of time, we would make it visible. And so to achieve that functionality with Phaser, the first thing we can do is we can update the visible property in our game object, and when we set that to false, our game object will not be visible in our scene. We set it to true, it will then appear in our scene and it'll be visible to the player. Next, in order to have our game object go from visible to not visible, we can use what's a timer event, and that timer event is going to be invoked every so many milliseconds or whatever we define, and then they can be used to run some type of code, and in our case, we would be updating our game object's visibility property. So now to do this with our node scripts, let's go back to our code. First, for our press enter text, let's make it not visible to the player. So in the UI, let's go to visible in our panel. We'll unclick the checkbox for visible. Let's save. We come back to our game. If we refresh, we'll see now our image game object is no longer visible. And so now, after our animation for our title image is complete, this will be the trigger for setting that visibility property. To do this, let's add a new script node. So under our game objects folder, we're going to do new. Let's do prefab file. For our name, let's do set visible action script. Now for our base, let's use our new custom class. So we'll drag in an instance of our node script with target scene. Let's save. We'll open up our JS file. So now we need to add in our execute method with our arguments. So I'm going to jump over to our move to action script, and I'm going to copy that first 2 lines of code. We'll paste that into our new script. And so on our object, we'll want to update our visible property. So we'll do object, we're going to do visible, and we're going to set this to a property on our instance of our prefab. So let's do this.visible. And now we need to add that to our prefab properties. So let's jump over to our scene. Let's do our prefab property. For this, we want it to be a Boolean. I'm just going to call this visible. By default, we'll go ahead and set this to be true. Let's save. Back to our script. We'll see our property now exists on our class, and now we'll assign that to our object. So back in our title scene, we want to make sure we choose our move to action script here. Let's add a new child script node. From our game objects, we're going to do set visible action script. Now we'll want to choose a target game object. Let's choose our press enter text, and we want it to be visible, so we'll leave our default value. We save and come back to our browser. Let's refresh. See, there's no image. After this appears, now our image shows up to our player. One last thing we need to do for our set visible action script is after we set our visible property, we need to call our execute children method. So if we have any child node scripts, we can execute them. So I'm just going to copy this line of code from our other script, and then we're going to go ahead and call that here, and let's save. So after we make our text visible to our player, we'll want to start our timer for setting our visibility property. To do this, let's make a new folder under script nodes. We'll do new, we'll do folder, and we're going to call this timer. So under here, let's do a new prefab file. For our name, we're going to call this timer event action script. All right, so for our time event action script, we're going to use our script. We're going to use the default script node block. Let's drag that into our scene and let's save. All right, so for our time event action script, the reason we extended our script node class instead of the custom class is for this script, we don't need to support having a custom target game object. When this script runs, we're not going to actually target any of the game objects in our scene. Instead, we're just going to have a timer event that's going to go off on an interval. And when this happens, we're going to use that to trigger executing the child script nodes that are attached to the script. And this will make more sense once we actually add in our code. So let's add in our execute method, and we're going to follow the pattern where we pass in our args. And so now to create our timer event, we need to reference the time and clock plugin on our phaser scene. So since we're going to reference our phaser scene, I'm going to jump over to the move it action script. I'm going to copy our lines of code here for our scene and paste it in. Now for our scene, we're going to use time, and now we want to do add event. All right, so to create our timer event, we need to provide a configuration object. For this, we need to specify how long we want to wait between each time this interval is going to run. So we're going to add in delay. For that, we'll add that as a prefab property. So we'll do this.delay. Next, for our timer event, we're going to want this to loop. So let's set that property. I'll set that to true. Finally, we need to specify our callback property. So for our callback property, our timer event is going to evoke this after however many milliseconds we provide to our delay. So if we do 1,000 milliseconds, what will happen is this timer event is going to fire after 1 second, and then it's going to trigger our callback. Another second later, it's going to fire our callback, and it's going to repeat this until we destroy or clean up our timer event here. So now in our callback, we're going to do this.execute children so we can invoke our child script nodes, and we're going to pass in our args. So now if we jump over to our time event action script scene, let's add in our prefab property. We'll do a number property. We're going to call this delay, and we'll set a default of 1000, and let's save. And now back in our script, we'll see our new properties added to our class. All right, so if we jump back to our title scene, after we make our game object visible, let's add the script as a child. So under timer, we're going to do timer event action script. And now we'll need to provide a script node to toggle the visibility on our game object. So to toggle our visibility property, let's make a new node script for that. Under our game objects, let's do new, let's do a new prefab file. We're going to call this blink action script. Now for our base game object, let's drag in an instance of our node script with target. Let's open up our .js file. And so now in the script here, we'll want to do logic that's very similar to our set visible action script. So let's jump over here. Let's copy our execute block of code. We'll come back to our blink action script. Let's paste that in. All right, so in our execute method, first we'll want to grab whichever game object that we're targeting. And now we want to update our object's visibility property. So instead of doing this.visible, we're going to reference our object. And now we want to set it to the opposite value. So if our object's currently visible, we'll want to set it to the opposite. So we'll make it not visible. And if it's not visible, we'll make it visible. Since it's a Boolean value, we can do this to toggle that value. Finally, we'll call execute children. So if there's any child node scripts, we can execute those. Let's save, come back to our title scene. Under our timer event, let's add that script. So under our game objects, we'll do our blink action script. For our target, we'll choose our press enter image game object. Let's save, come to our browser, let's refresh. Our image should appear, it'll disappear, and then on our timer interval is now going to keep disappearing and reappearing. Alright, so once the player clicks on our title scene, we'll want to hide our title image, and now we'll show the instructions to the player. So if we jump back to our code, we should be able to make use of our onPointerDown action script that we previously added. However, this current script expects us to be attached to a game object, and we're going to update this functionality to use our new custom class, and then that way we can choose our target game object based on our custom code. To do this, let's open up our onPointerDown action script scene file. Now in our scene file, let's delete our base root game object here. And now let's drag in an instance of our custom class. So we'll do our node script with target scene. We'll drag that in, let's save. Come back to our JavaScript file. We'll see now our class is extending our new custom class. Next, we're going to update our script to, instead of using our awake method, we're going to use our execute method. So let's add in our args. Now we want to get a reference to our game object. So let's come to our blink action script. Let's grab this line of code here where we grab our target object. Let's paste that here. And now anywhere we're referencing this.object, we want to replace that with just our object variable here. So let's do that update now. And so the reason we're changing from the awake method to our execute method is we might have use cases where for our click events, we don't want this to register automatically when our component is created. Instead, we'll want something to invoke it to add that event listener. And so we jump back over to our storyboard. One good example of this is when our title scene is clicked here, we're only going to want to do one click event. And when that happens, we'll show our game objects. And then on this scene here, we'll want to do a second click event where when that happens, we're going to fade out our scene. And then that would be our trigger for starting your actual game. Now for that action, for that second click event, we don't want that to be registered automatically. Otherwise, we'll start fading out before we even read the instructions. We don't want to register that until we arrive to this state in our game. And so by placing this logic in our execute block, that's going to give us that fine-grained control over when this code will run. So now back over in our title scene, we're going to target our onAwake action script here, since we want to listen for our click event as soon as our scene first starts. So let's add a child script. Let's do our game objects, and we'll do our onPointerDown action script. Now for our target game object, let's choose our background image game object here. Let's save. Let's update our property. We're going to set once because we only want this to fire one time. So now let's choose that script. Let's add a child script, and we're going to do our game objects. We're going to do set visible. We're going to want to hide our title text. For our game object, let's choose title. We'll set visible to be false. All right, so after we hide our title text, now we want to make our instructions available. So if we choose our onPointerDown action, let's add a new script. For our game objects, we'll do set visible. Now for our target, we're going to choose our instructions image game object. We'll do save. If we come back to our browser, let's refresh. Now, after our title appears, we click, we'll see that we hide our title text, and now we show our instructions to the player. All right, so let's do one more test. If we click before our title image game object gets into position, we'll see our instructions still show up, and we still hide our title image game object. So now that our instructions are visible to our player, we just need to register one more click event, and when that happens, we'll want to have our camera fade out to black. To do that, let's come back to our project. And so on our PointerDown action script, Once this is invoked, we'll want to register another pointer down event listener. Let's add a new script. Let's go into our game objects. We're going to do onPointerDown action script. For this one, we'll target our background again. We'll also set our once property, so we only listen for this event one time. And now we want to trigger our fade out effect on our camera. So let's add another script. We're going to our camera, we'll do our fade effect. For duration, we'll do our 1000 milliseconds, and we're going to target fade out complete. Alright, so if we save and refresh our browser, let's click on our scene. If we click one more time, we should now fade to black. Perfect. And so now this would be our transition point to actually start our game, and then we can have a fade in effect on our level. Alright, so with that last change, that actually wraps up our title scene example project. So between our two projects, we've seen a variety of ways that we can use script nodes in our project to add core phaser functionality to our game. And by creating our script nodes in this manner, we make them reusable across all of our projects. And so far in all of our examples, we've created all of ours from scratch. So that brings me to one last topic I want to cover before we wrap up. So since our script nodes are reusable, we can create reusable libraries that we can share with others. And that's exactly what the Phaser team did. So in the documentation for phasereditor, there's a section on the script node libraries. And one of the libraries that is called out is the editor scripts quick npm library. This library has a variety of node scripts that you can easily utilize in your project. So we won't be covering how you can install these in your project, but I just want to call this out so you're aware of it. So in the documentation, if we click this link, it's going to take us to GitHub. And so on the GitHub documentation page, there is information on how you can install this package to your project. And at a high level, the library offers core scripts for your game objects, for Arcade's physics objects, animations, audio, your camera, doing things with random events, and much more. All right, so we quickly go through the documentation. We're just going to see there's a wide variety of scripts that are available to us. For each of these groups, it's going to break down which scripts are available. Just as an example, we have scripts that target specific types of game objects, ones that target events, actions, so really similar to the things that we built today. Versus if we look at like Arcade, we're going to have things that are tied to like velocity in our game objects and much more. And so for each of these groups, these are broken down by what script is available. It has some details on that class and how you can utilize it in your project. And so as we just scroll through here, we can see there's all kinds of different scripts available to us. And so this is just something to keep in mind when you create your next phasereditor project. You can easily import this package into your project and you can start utilizing these scripts right away. And you don't have to start from scratch. Plus, if you create your own custom scripts, you're able to create an npm package of those, and they can also share them with others. So in the description of this video, I'm going to include a link to this documentation page, as well as the GitHub repo where you can find those scripts. And with that, that brings us to the end of our deep dive into script nodes in phasereditor v4. Let's quickly recap what we covered. We started with the basics, what script nodes are, and how they work with phasereditor. You saw how to create, configure, and change script nodes to build reusable, flexible game functionality. Then, we created a basic button and a title scene where we explored how script nodes can handle complex interactions and animations. With script nodes, you have the power to simplify your code, speed up your development, and make your game logic reusable across multiple projects. One key thing to remember is these nodes are totally optional, but can add a ton of value when you're aiming for modular, visual game development in phasereditor. And just as a reminder, in the description of this video, there'll be a link to complete source code for this project. As always, thank you so much for watching. If you found this tutorial helpful, please like and subscribe for more phasereditor tutorials. And as always, feel free to drop any questions in the comments. I'd love to hear what you're building. Until next time, happy coding.